Good evening, dignitaries, academicians, and all the active participants. Welcome to the day 2. To continue with the seminar, I would like to call Mr. Dhaval Mehta.
Yes, ma'am.
Yes, sir. You can continue.
Okay, fine. Thank you. I'm sharing a screen with you, all of you. Please confirm this thing, right? And there is some rapid fire questions which I'm asking, and you'll have to answer very quick so that we can have a recap in this matter. Yes, ma'am. Can you see the screen, all of you? Say yes or no.
Yes, sir.
My first question to all of you is, what is stationarity? Anybody who wants to answer? Anybody wants to answer? Fine. Barkha has written mean constant mean. Anything else? Right. Variance constant and covariance constant. Very nice. So we came to know that the mean is constant. We came to know that the mean is constant. Variance is constant. And covariance is constant. Now my question is, what is the difference between variance and covariance? What is the difference between variance and covariance? Anybody who wants to explain this matter? Anybody? Okay. Fine. It happens. Let's understand this thing again. Suppose this is the ECG of the heart. If I'm talking about that the mean should be constant, then I'm saying that this should be having mean returning series. The series goes out and again comes back to the equilibrium. It goes out and again come back to the equilibrium. That is whole thing which is related to mean returning series. Variance is constant. That means that this thing is constant. Now I say, now what is the explanation for covariance? It means that suppose if I take the snapshot of this particular area and this particular this area, will both the series look same? Say yes or no. Will they look same? If I take the photograph from both the areas, will this look same? It means that this photograph and this photograph is same. It means that covariance at the time interval I, J is equal to the covariance at K and L, which means it is constant. Right? Shall I proceed further? Is it clear? Is it clear? Right. Now, this is the idealistic situation which everybody wants. But what to do when I don't have the stationary? What to do? What to do? I don't have stationarity. Make it stationary. Stationary. What are the things which are available with us? There are two remedies which are available. Yeah, one give medicine and another is surgery. Medicine is log, surgery is dy by. Right? Now our original ARIMA model, which is there, ARIMA, it gets affected only if we do dy by dx. But if we take the log of the series, it does not affect I. It does not change the integration of I. It means that if you are changing just the series by log, your I will remain always 0. And that's the reason we say it is medicine. But here, if I take dy by dx, it is a first differentiation and your series becomes I1. If I take the second differentiation, the series become I2. Right? Till how many differentiations we can go? Anybody wants to answer? How many differentiations? We should not do more than 2 surgery on the patient. Only 2 surgeries are allowed, not more than that. Because every time we do the surgery, we are losing the data. We are losing the heavy information every time. And it may happen that at one of the surgery, the series may explode. It may happen. Is it clear? Now, once a series is established, we have made it clear that the series is established. Now we want to use the models which can predict this series. So there can be a possibility. Let's say, for example, if I am saying that there is YT, right? YT. On that day, did I discuss anything which is related to ARIMA? Say yes or no. ARMA terms, did I discuss anything related to that? Nothing. ARIMA, AR model, MA model. Did I discuss? No, not equation, just basic. What is AR and MA? Anybody recalls? Yes, fine. If you recall this, let me give you an example. I have taken a point YT and I am passing a line here. And this is an error. Right? Now we go one time period back and we make it YT minus 1 and epsilon T minus 1. So if I am making a model considering only the past data, then this is a AR model. And when I include the errors in the model, errors also, the past errors also, it is MA model. I had given an enough explanation that why error we are considering. Basically, errors are like a memory cells. Very good memory cells. I'll give you an explanation to this. That you started typing for the first time and you committed, this was the actual letter which was to be pressed, letter on keyboard. So you committed more mistakes, and the letter which you typed was quite away, and it was deviation from the actual when you started typing for the first time. Over the period, your brain started learning that on keyboard the letters are located at this points, and your error went on decreasing. So you are learning from errors. Similarly, here also we are considering the error component here to learn our model. Is it clear? Shall I proceed further? Any questions are there? Please ask. Is it clear? Shall I proceed further? Hello. Please write in the chat box whatever, at least yes or no, you should write, right? Okay. Now we are making a model and we say that my current yt is equal to alpha plus beta 1 . So whatever you do, whatever past error also you consider, but still there will be always an error in your model. Is it clear? Now these terms are known as AR. These terms are known as MA. Is it clear, all of you? Is it clear? Okay. Let us proceed further. My past data, my past error is affecting me or not, that I will capture from correlation. And when I consider the correlation between the past data, say for example, error of first year, error of second year, error of first one period back, second year back, and there will be some data here. Here the data will be a little bit less. Here the data will little bit less because it is 2 minus. Now, if this shows a strong correlation, right? If it shows strong correlation, then it will, if error at time period t shows strong correlation with 1, it will show a very big spike, how much it is correlated at t1. If it is normally, if it is less correlated with t minus 2, it will t minus 2, it will show a small spike at t minus 2. Then t minus 3, t minus 4. These are all correlations, right? So considering this, we will be having ACF and PACF. ACF is like carrying out the correlation between consecutive, and PACF is carrying out the correlation between the successives, E to t minus 2 directly, and therefore PACF is a signal for AR terms and ACF is a signal for MA terms, right? Is it clear? We will come to know from the pattern of ACF, is it a MA term, or from the pattern of PACF, we will come to know is it a AR term or not. Clear? Shall I proceed further? Shall I proceed further? Say yes or no. Right. Now, what are those patterns which we have to study? There can exist only three types of patterns. In any uh, in any data, it can only have three types of combinations. ACF is geometric and PACF is significant till P lags. MA is significant till P lags, and this is geometric, and geometric. Let us see and try to understand what do they mean. So if I talk about this scenario, ACF is geometric. So it can happen that when I plot the correlogram, which is a representation of the correlation with the previous legs, then if ACF is geometric, it means that it can have a sinusoidal shape like this. Positive relation, then negative. And PACF is significant on one leg. After that, it phases out. This means that it is AR process. It is a AR process. This is AR process, right? Because this is significant. Now, there can be another story to this, that this is having significant spike, and this is sinusoidal or exponential like this, any geometry. Then this is MA process, moving average process. It means that it will be having more MA terms. This will be having AR terms. Third possibility is that both of them are sinusoidal or exponential. This is the clear case of ARMA terms. Is it clear? Is it clear? Shall we proceed further? Is it clear to all of you? Say yes or no. Okay. Now open the file. In this case, if both are significant, then in this case, if both are significant, no, it can be a geometric. Both will be geometric. One will be significant. That combination will be only there, right? That combination will always. When we will see the data, no, you will come to know how it is happening, right? All of you, let's go there and try to see the file which I had already sent. The file name is, which was a file name which I had sent, table 8.8. Done. Now just click on GDP. And view correlogram. Just see the correlogram level. Now, what you can say about this? This is ACF function. This is PACF function, and the correlation is significant. And these are lags: 1 lakh, 2 lakh, 3 lakh, 4 lakh, 5 lakh, and 6 lakh. Right? What do you think? In GDP parallelogram, ACF is significant. No. Where is the spike at? See the spike. It is at where? It is at which location? PACF. And this is sinusoidal. So if this is having a spike, it is an indication of what? Because this is MA, this is AR. It is an indication of what? It is an indication of agreed. But just see this guide. ACF is geometric and PACF is significant till P lag. Right? How many lags are significant? One lag. So it is an indication of what? It is a AR process, right? It is an indication, clear-cut indication of AR process, right? Okay. Now, one more thing which we have forgotten is before recommending any such thing, we have seen this, but we will have to make this stationary first. We will have to make it stationary, and therefore we had used some commands to make it stationary. All of you again use that command dGDP equal to dGDP, first difference, enter, generate dGDP equal to dGDP equal to 1, enter, generate the two series. I am sending the command in the chat box. Done? Are you able to generate a series? Are you able to generate a series? Now, can you see that the series has become stationary? Just see, as the series becomes stationary, view from parallelogram at level, are all spikes inside this? Are all spikes inside the dotted line? PACF lag at 3. Yes, Bishal Dev. Very nice observation. Very nice observation. See, Bishal. See, this is going out of the dotted lines. But we have to more rely on these values. If these values are more than 0.05, it means that these lags are now no longer significant. Is it clear, Bishal Day? They are above 0.05, right? And therefore, they are not significant. Very nice observation. Good question. Are you all clear? Are you all clear? But I am not clear. I want to ask you a question. There is a parallelogram. There are two parallelograms, right? This is the parallelogram of original series, and this is a parallelogram of different series, right? We will take the judgment on the basis of what? That this is a AR or a MA process, the original series or the different series. research scholars get confused most of the time. Then, sir, we are not able to understand which one I will consider. I hope my question is clear and loud. Yes, Rohit sir, you are completely right. We will consider the original series because by differencing the original series, we have destroyed the pattern. And as a pattern will get destroyed, we will never come to know which processes they are following. And therefore, we will detect from always the original series. Is it clear? Shall I proceed further now? Now we have to give equation to this model. There are some methods which we will have to understand. You can either go from quick estimate equation 1 or you can write the command here. Remember that whenever you write the command from here, you require the command line. For example, I am trying to run the regression, so I'll use ls ddgdp, the difference series C AR1 MA1. It means that I am taking first order regressive term and one period back model. Now voice is clear, sir? Dr. Srivastava, my voice is clear now? Hello? Are you all able to listen me? Am I audible? Dr. Srivastava, there is some problem at your end. Okay, now enter this and an equation will appear. I will have to do something. Now close this window. 1, 2, and just see the values of P. If these values are more than 0.05, these terms are not significant. I repeat again, if these values are more than 0.05, they are not at all significant. They are not contributing anything. Yes, I am repeating the same thing. Formulation. The formulation is I'm sending the command in the chat box. Please run this command from here. The same equation you can run from here also. Quick estimate equation. You can go from here also. I am repeating again. Quick estimate equation. Now, when you are in this window, you don't need to write down the first line or the first word of the command. It knows very well that you want to run regression. So you'll directly write down ddgdp CARMA1. Enter. You will get the same set of results. Please check. Are you getting the same thing? Say yes or no. Are you getting the same thing? All others, please write your response. It matters a lot. If you cannot write the whole word, just write down yes, why, or you can also write only why. Right? So we are not able to carve out the model because here all the p-values are more than 0.05. Now, we want to identify which model this series is following, or rather, what is the pattern of this data? It's following which trend? I should rely more on AR, MA, both, or the combination of them. Sir, please repeat the process through quick. What to write in empty box? See, sir, you are using a term to denote PAC graph. What is that term? You are using a term to denote PACF graph. PACF. What we call which term? Barkhaji, which term? Which term? This one? This one? PACF is for AR and ACF is for MA. Barkha ma'am, are you there? Is it clear? Okay. Now, let's go back. There was a question that what we are writing in the quick estimate equation. I will close this, delete. Yes, quick estimate equation. See, when you are here, you don't need to write LS because it knows that you want to carry out the least square, and therefore you should start with the first term, DDGDP, dependent variable, whose model is to be created. C, right? AR1, first term, MA1, enter. DDGDP is the 2 times different series, Dr. Srivastava. This series we have considered after making it stationary, and therefore we are using how to cut. I'm not getting Dr. Srivastava. Can you please explain? How to create. I think you have joined late, sir. I'm sending the command line here. Please copy this command line, sir, and it will get generated. I'm sending it in the chat box and it will get generated. Please check it. Dr. Srivastava, the series will get generated. Right. Now, to make any model, the first thing is that this term should be significant, or in other words, they should be less than 0.05. Prima facie, we have lost the battle here. We have lost the battle here. Sir, what about negative? Does it sign matter? Mohit Saini, listen carefully. Still, we have not cleared this. The interpretation comes much later on. First, we will have to clear this. We will have to make the term significant, then this interpretation will come. At present, we cannot do anything because these are all more than 0.05. It means that there is no contribution, no significant contribution coming from that. Sigma square is a new term which has been introduced in EViews after EViews 10. Now, for years together, at least for 2 to 3 years, I was also not getting explanation from this. I contacted the original company and I posted a message to them that what is this new term sigma square which you have introduced, which was not there in earlier versions. The reply which I got was that, sir, still original company had written to me, sir, still we are trying to figure out. I can show the mail, right? Rohit Lalaji. After reading the books and after going through the manual, they came out with the conclusion that this sigma square is a volatility. Listen, I am answering the question. This sigma square is a volatility which is being generated. Now, this volatility you don't have to consider in your equation, but you will consider that equation whose volatility is minimum. Whose volatility is minimum. Say, for example, you are having two models whose volatility is Z. So you will consider a model whose sigma square is least. Is it clear? Shall I proceed further? Is it clear, all of you? Shall I proceed further? Right. Now, we have not got any clear-cut equation. So now I am running my car on Tesla mode. ED GDP, C, AR. I don't know which terms are going to affect. So 1, 2, I am writing 1, 2, 4 terms, including my model. MA 1, 2, 4, including my model. 1, 2, 4, MA 1, 2, 4. I am copying this thing in the chat box and you will be able to run it. Click OK. Yes. The situation is more grave now. Oh, sorry, I had already. Oh, it only went to Barkha, right? Oh, wait. Done. Did you got the result? Is any of the terms significant whose p-value is more than 0.05? Any term significant, or still we have not got anything, we can conclude anything? So there is a problem. Now how to solve, how to resolve this problem? So we will take the help of our original parallelogram, which was indicating that this is a AR process. Okay, let us run the AR process and see, was it correct? Quick estimate equation LS DD GDP C AR1. I have also made the same mistake. LS should not be used here. Done. Yeah, you want the equation? I am sending the equation. It is here. DDGDP C AR1 let us check that this equation which is there, how is it the scenario for MA1? Okay, we have to remember this equation, right? So either you can do one thing, you can go in object, store to database, this thing, and you can say, click yes. No database was found, just a minute. Object, store to database, and no, I want to store it here only. Just a minute. Object, consider. From here only we are going. Yeah, click OK. Name, click OK. And this equation will be stored. Name and OK. So whenever you click this, this thing will always appear. Name and equation. Right? I am writing this equation DDGDP CAR1 done. Now I'm running another equation that I was having some doubt that is it a possibility that this is MA process DD GDP C MA1. Does anybody think that this is a MA process? Right. So it is a clear-cut thing that it is. You can save this also, equation 2. So I don't consider this model because the terms are not significant, right? Now, is there any procedure which can detect the things on its own? All those who are working in the student light version, possibly go in click on DDGDP and just a minute. Yeah, this one, PROC, automatic ARIMA forecasting. Automatic ARIMA forecasting. Many of you must not be having this option. Is it so? Say yes or no. Are you having this option? Say yes or no in the If you don't have this option, no need to worry. Go in add-in, download the add-ins, and possibly in student version, this may not be there. So you can go here and ARIMA selection, ARIMA select, ARIMA select, install. Click OK. Yes. Install successfully. OK. Close. Proc. Automatic ARIMA selection is now ready. Done? Is it done? Is it done? Shall I proceed further? Hello? There is no add-in option. Possibly you are working on student light version and therefore it may happen. Student light version don't have this. Yeah, student light version don't have this facility. The professional version is having this facility. No need to worry. It's just a simple explanation. See what it can do. I will go for automatic ARIMA selection. It will ask me how many independent variables are there, right? So I have to just write down my independent term is C only, because I'm not consider anything apart from this independent terms. Maximum AR terms on which I should work is 2. Maximum MA terms should be 2. Maximum differentiation which should be carried out is 2. And the criterion, the best model should be selected on the basis of Akaike information criterion, or you can also change it to Squads or Hanen-Quinn criterion. Click OK. After this, it will immediately give you the result that according to me, this is AR0 MA2 process chosen differencing 1. Is it clear? Now it has given you a different set of answers. It may happen that you get a different set of answer, but I will not take this answer. Why? Because when you are having an option that the things can be explained by only one parameter, AR1, and here you are taking 2MA, always select the model which explains by considering list number of variables, list number of parameters, AR1, only one parameter, MA2. So it will be MA1 and MA2. So this is the first rejection here. Second rejection is that on first difference, our series was not stationary and it has worked on first difference. So we don't accept the result of automatic mode. Okay. Again, we will go back. Again, we will go back and try to figure out that what will be the scenario when we make the things 1-1. Options, automatic ARIMA selection, and now I make this as 1, this as 1, and click OK. Chosen AR1, MA1, again differencing 1. So again it has done a mistake. So it is possible that you will have to do trial and error. So you will have to do all the combinations according to the automatic mode and the manual mode. There is no guarantee that whatever result you get from the automatic mode is optimum. Clear? Shall I proceed further? Any questions are there? Please ask. Any questions are there? Please ask. Shall I proceed further? Say yes or no. Okay. I will again go to the basic point. DD GDP var. Var is, what is var? Still we are not on var. You are asking something else, sir. You are asking me something else, sir. Now let's see the methodology which was given by Box Jenkins, right? So his methodology was identification of the,
Sir,
yes, sir.
Sir, sorry, actually, due to network problem, I was late. I'm sorry for the same, sir. Actually, I'm trying to create this DDGDP, but unfortunately, my EViews, that is student light version, so is unable to create the same. That is why
No,
that is
no,
why.
no need to worry, sir. We are
Sir,
there with you. No need to worry.
please.
Can you share your screen with me?
Yeah. Sir.
Organizers, please allow Dr. Srivastav to share the screen. Please promote him. Organizers, please allow
Most desirable participant in screen sharing.
Dr. Srivastava. Please allow Dr. Srivastava to share the screen. Arunima ma'am, please allow.
Yes, sir, doing.
Yes, sir. Show me your model.
Oh, sorry. Where is my? Is it visible to you, sir?
Yes.
Yes, sir. This is my.
Yeah.
So wait a minute, sir. I'm again starting. That will first of all, sir.
Yeah. Just a minute.
So this is sir table.
Yeah. Open it.
So this is GDP.
Yeah. So you write down in the command line.
Yes, sir.
Generate. GNR. Generate.
GNR.
Space.
Yes, sir.
DGDP equal to D.
D.
D. D.
AD.
D. D for Delhi. No A. No A. D for Delhi. Into bracket. GDP, comma 1. Enter. Second, generate. Space. DDGDP equal to D, comma DGDP, 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 comma 1, bracket over.
Oh, bracket out.
Yeah. Enter.
It's second.
Okay. Now write down LS
LS.
space DDGDP space C
There's constant, sir.
constant space AR1 AR into bracket 1. Enter. Got it?
Yes, sir. Yes, sir. I got that.
Okay. Thank you, all of you.
Thank you, sir.
Right. Now I'll start sharing my screen again. So there was a query that how to activate ARIMA selection. It is very simple. Go in add-ins, download add-ins from here, Others, please mute the mic. And there is something which is known as ARIMA selection. ARIMA selection. Do it. My windows of ARIMA is not small. Add-in option is from here. Add-in, manage add-in, and ARIMA selection or download ARIMA. And after that, you go in add-ins, automatic ARIMA. Yes, Mohit Sani, you may be right. Depending upon the versions, this ARIMA windows they have made a lot of corrections in this, or a lot of changes have been made on this. And therefore, EViews 8, 9, 10 all have different ARIMA windows. So it may happen, Mohit Sani. No need to worry. Right? Shall I proceed further? Shall I proceed further? Say yes or no. Okay. Now, there is a process. The process is that first we have to estimate that which series it is. It is an AR or MA. Then after that, we have to do diagnostic checking. The methodology which is applied, this methodology is known as the Box-Jenkins methodology. Now we will read first step. Calculate the ACF and PACF of the raw data and check whether the series is stationary or not. If the series are stationary, go to step 3, dialect. Examine the graphs of ACF and PACF, which models will be good. If they are not, either take the logarithm and first difference of the raw data and calculate ACF and PACF of the first logarithmic difference. That we have already done it. Estimate the models. For each of this estimated model, right, we are trying to find out which model will be best. These things we have already done. Identification has already been completed. Indication of ER and MA process, this is also done. Right? Now, after doing this, we had generated one series, that is generate DGDP, first difference. This is also the method in which I can generate the same thing. So we are having the lags here, right? Now, let us go further, and we have to select the best model. Model should be having a significant coefficients. I had already given you the instructions that if the p-value is less than 0.05, then only you will accept the coefficients. The volatility should be lowest, sigma square. R square should be highest. The explanatory power of the model should be high, and it should be having lowest Akaike information criterion or a Schwarz criterion. Let us see this way. If I am running ARIMA 111, ARIMA 110, ARIMA 011, right? And I get this model. Be very careful. See, all these combinations we had run AR1, MA1, all these processes which we have run. I got sigma square, volatility, adjusted R square, AIC, and SBIC. Now, what is my conclusions coming from this? First of all, we have to go for the model whose volatility is least. Which is the model whose volatility is least? Whose volatility is least. But you all have answered the volatility is least, but we don't have any significant coefficients here. So we have lost the battle here. There is no significant coefficient here. So now we will have to go for the next selection. Which is the selection which I should go for? I will go for 011, right? Now let us see. If I think of this, one parameter important, one coefficient is important, sigma square lowest, adjusted R square should be highest, right? This is not possible as there is no coefficient. This is possible. So out of this two model, this is having high R square, low volatility, low AIC, low SPIC, and this model has won the race. So ARIMA 011 is the best model for our data. Clear? Is it clear? R square should be high, sigma square should be low, AIC should be low, SBI should be low. Clear? Would be the decision if 110 got adjusted R square 0.07. Would be the decision if 110 got R square 0.7. Which one? Mohit Saini, would be the decision if 110 got adjusted R square 0.70. What would be the decision if adjusted R square you got 110 as 0.70? So there is a conflict here and we are trying to resolve the conflict. That Mohit Saini wants to ask that what to do if this R square was more here and the criterions were less here. Good question again. We never ever rely on R square in time series, and you will never get 0.7 answer in ARIMA. But if you get such scenario, you have to rely more on Akaike information criteria, EIC and SBIC more. Lower the better model. Right? Is it clear, Mohit Saini? You rely more on AIC criteria. Right? Lowest AIC. Yes. Lower the better. Now we have made the model. Now after that, what is our thing which we want to see? We will have to carry out some statistics, right? And these statistics are, again go back here, and we have generated DDGDP. Sorry, this model is already generated. Quick estimate equation and DDGDP. C AR1 was the best model which was generated. Enter. And this is the best model which was generated, right? Now there are some diagnostics checks which we want to do. That is my model performing better or not? So for that purpose, you go in view, residual diagnostics, and first thing which you should generate is parallelogram Q statistics. All of you follow my footsteps. View, parallelogram Q statistics. Legs to include 12. Click OK. Now these are the residual graphs of your model, and here neither of the spikes should be significant. Neither of the spike. Is it so? See. Okay, so all of you just see how to carry out all this. Then I will take the explanation. Then again you go in view, residual diagnostics, normality test. This should be normally distributed. Your residual should be normally distributed. I'll explain everything one by one. Don't worry. Or in other words, this p-value should be more than 0.05, right? So most of the time, scholars get confused where to take less than 0.05 and where to take more than 0.05. Yes, second leg is significant, I know it, right? Most of the time, scholars get confused. That, sir, we are not able to understand when to take less than and when to take more than. See, when you are evaluating the coefficients, overall model, and here when you are testing residuals, the desirable p-value here is less than 0.05. And here desirable p-value is more than 0.05. This is the basic difference in these two cases, right? This you should remember. So if the residuals are having p-value more than 0.05, it is good sign. And here if it is less than, it is good sign. Now what are these errors? Let us try to understand. Now, what are these errors? We try to understand. Be with me. Pay attention. You have created the model. Let me try to take some more example, another example. You have made a model y is equal to this also. You have made a model which is blood pressure is equal to 120, the constant, plus 1.1 times of age plus 0.3 times of weight. Is it clear? This is just a model. This is just, I'm giving you an example, rough example, very rough example. No such model exists. This is a theoretical model. So what I'll do is now, you are somewhere around 50 participants. So I'll measure the blood pressure of the first participant by the spigomanometer, which is an actual. And then I will measure theoretically. Do you think that these two blood pressures will tally? One through the actual instrument and another the theoretical equation. Do you think they will tally for each and every participant? Say yes or no. All of your answers are necessary. Exactly. It will not tally. It will not tally. 101% it will not tally. No, sometimes it may tally, sometimes it may not tally. You are right. You can never ever minimize error in your model. Right? Why? Because this error will always creep in your model. Because there are many variables which can affect your blood pressure and you have not considered all of them in the model. There may be interaction effects, there may be quadratic thing, and all these things are not considered, and therefore error will always be there in the model. We cannot get devoid of the error in any model. So we have understood one thing, that I cannot avoid the error, but I am saying, or rather I am confined, I'm allowing error to fluctuate in the range bound, right? In the range bound. Now, say for example, today the gold price is 59,000. And I have made the model which will predict tomorrow's gold price as, say for example, tomorrow's gold price, I'm saying actual and predicted. And I will write remarks. How is my model? Be with me. I predicted that tomorrow it will be 70,000. And the actual turned out to be 60,000. Is it a good model? Is it a good model? And therefore, I will say no. And what was the error? Actual minus predicted, negative error. Now, I predicted that tomorrow the gold price will be 45,000. And it turned out to be 61,000. Is it a good model? positive error. Now, if I say that I predicted that tomorrow the gold price will be 60,000 and the gold price opened at 60,500. Is it a good model? Yes, we are nearer to it. We can definitely never have an exact thing, but we are near to it, and therefore this is a good error, good model. Now it means that if my prediction is nearer and nearer to the actual one, my model is good, and therefore my model is considered good when my chance of committing very large positive error is very less, and the chance of committing very large positive error, negative error is very less. In other words, when I develop this thing, a normal distribution plot is developed, and if I say that the mean is 60,000, then the model committing very large positive error or negative error is very less, and 45,000 is very less, and therefore my model will be considered good is if as I go nearer to the mean, the predictive power increases, then this model is good one. Is it clear? And therefore in residual I require normality. One thing. Is it clear? Shall I proceed further? Say yes or no. So this is normality. Now comes, let's say for example, this is y is equal to alpha plus beta x plus error. This is our love story. And this is the villain. Right? We cannot avoid the villain, but we can definitely put villain behind the bars. Now putting the behind the bars means this error, say for example, this error should not increase its power in the, when it is in the jail, it should not increase its power or decrease its power. And that thing is known as heteroscedasticity. Right? Clear? Is it clear? The error should not increase or decrease. Second, the error should not, okay, all of you have understood this concept that error should not increase or decrease. My question is, why decreasing is not allowed? We had discussed this thing. We had discussed this thing. Yes, we had already discussed this thing. Right. Okay, good. So the error should not be having a correlation with other error, and the multicollinearity should not be there. So let's go there and try to run one by one. See this normal distribution. It is there. See p-value. It is more than 0.05. So there is a normality in the residual. Done. One case won. We have won the case. Clear? For normality. Right? This is clear. Let's see other things which are there. Residual diagnostics, parallelogram Q statistics. Click OK. Autocorrelation absent. There is no friendship of the error with other errors except this one. This is little bit detrimental, but anyway, we can report it. We can say that the first leg was significant. There is no problem. Then comes the heteroscedasticity. Go in heteroscedasticity test, Roos-Pagan-Gottfried test, click OK. Insufficient numbers of coefficient to test. Okay. Normality affects heteroscedasticity? No, it does not affect. View residual diagnostics, heteroscedasticity. Why don't we go for the White's test? Click OK. Go for White's test. And you should see this value. You should see this value. Is it more than the middle one value? Is it more than 0.05 or less than? Is it good or bad? Is it good or bad? This is a test for residual. Is it good or bad? Right. Very nice. Now, what are the null hypotheses of all this test? And why do we go for such thing that the p-value should be more than 0.05? So if I am running the test of normality, my null is residuals are normally distributed. And therefore, desirable is p-value should be more than 0.05 and we accept null. In case of autocorrelation, null is no serial correlation found. And in case of heteroscedasticity, residuals are homoscedastic. And this is the reason we require p-value in case of residuals to be more than 0.05. Is it clear? Say yes or no in the chat box. Shall I proceed further? Shall I proceed? No, three problems exist. How to remove such problems in our model? Anshul Agrawal, case of stock market is completely different. That I will address. We are moving to the next level. I'll address Anshul Agrawal. See, econometrics can be learned in 3 days, 1 month, 6 months, 6 years. It's a continuous process which is there, which we have to learn, right? Shall I proceed further now? Now, when we are done through this, the model has been created, right? I will close this. I deleted the equation only. Quick estimate equation, DD GDP, CAR. One. Now, all of you are in this window. Say yes or no. All of you are in this window. Now, Dr. Srivastava, come in this window where the equation is. Now there is a small tab, forecast. Right? And here it will be doing the forecast for entire sample, which we don't want. We want to say that the model which we have created, DDGDP, do at least compare last 2 years result. So 1972 to 1974 on the basis of the model which has been created. Click OK. And you will get the answer. Done? Is it done? Is it done? You got it? Now your model is good if the blue line is between these two red dotted line. And the forecasting is good. Is it clear? But this is related to how good the model is. But there is one more thing which we will have to do, minimize this. And there will be a new series which have been generated, the forecasted series, F. Can you see? The forecasted series will come into the existence. Is it there? Is it there? Now, select the original DDGDP, original series, and forecasted series, open, right click, open as group. Is it there? Now, if you will see the initial year observations, they are all same. But just focus on last 2 years observation. The actual is 12136 and the predicted is 4849, 2709 and predicted is this. So this is a prediction which I have got, right? Go in view and graph and click on OK. And you will come to know the prediction. It is very clearly predicting. See, here the spike is there and the same spike it also got. If you want to have the microscopic view of the series, expand the series like this and have only the last 2 years. Done? Is it done? Is it done? Say yes or no. Right. Let us come back here on the new thing which I am starting. Most of the time, scholars face a problem that, sir, when to use ARIMA, when to use regression, when to use VAR, when to use Beckham, where to use ARDL. This is a very difference is huge in actual and predicted. I agree, Rohit Lalaji, Rohit sir, I agree. I agree in this matter. And by experience, this was just a demo presentation. By your experience, this difference should be minimized. Right? Okay. I have seen scholars facing a problem that when to use ARIMA, when to use VAR, VECCAM, ERDL, and most of the time there is a confusion. This confusion can be sorted out in one simple way, that first question you should ask is, how many series are there? If it is only one series, as we talked about GDP, you can use AR model, MA model, ARMA model, ARIMA, and SARIMA, seasonal models. Clear? Is it clear? Is it clear? Shall I proceed further? Next question comes is, what to do if there are two series? So the next question arises is, are all series stationary at level? Is everything stationary at level? Stationary at level means the base series is stationary. All of them. Two variables are there. If the answer is yes, you will be using regression analysis, simple OLS. And if no, then try to differentiate. Take first difference or second difference. If after first differencing, are they getting stationary? Okay, are after first differencing, does the series get stationary? Yes. Use again regression. Right. And after first differencing, if the original series don't get stationary, but their errors get stationary, you use error correction model, ECM. This when we will do, you will come to know, right? Because today we are going to start this component only. This has been done. This I am doing it right now, regression. We will have to see, we will have to focus on errors. My question is very simple. If the series is stationary at level, it means that all of them are stationary at level. Normal regression will serve your purpose. But after doing surgery, this, have all of them become stationary at first difference? Again, use normal regression. But if this, if instead of getting stationary, errors are stationary, then there is a very fair chance that there can be a co-integration in the model which we will have to detect, right? Which we will have to detect, right? So let's go back in the model and say, for example, if our original series are capital, employment, and GDP. Three variables are there. And I assume that they all are stationary at the level. Is it clear, all of you? I assume that they are stationary at the level. Is it clear? Shall I proceed further? Say yes or no. This is my first assumption, that they are stationary at the level. So I will carry out a regression, quick estimate equation, and I'll say that my GDP is equal to C, constant, capital employed and employment. So I want to predict that my GDP is based on what? that my GDP is getting affected. Sir, if we have our original series convert into log and it is stationary at the level, can we use regression or not? 101% you can use it, Anshul Agrawal. But remember one thing, that if you have converted your series into the log, the interpretation will change. That I will explain. You keep this question reserved today only. After some time, I will answer. You keep this question reserved. That's what to do in log. Because I'm going to run here only, right? Click OK. Yes. First thing which you should see is the p values. Are they significant? Now, when you are running normal regression, R square is of most importance. It should be more than 0.7 and it is reasonably good. So this value should be less than 0.05. This value should be less than 0.05. Is it clear? Is it clear, all of you? But there is one checkpoint. And the rule of the game is that R square should never be greater than Darwin-Watson statistics. If R square is greater than Darwin-Watson statistics, your game is over. Okay. You have lost one life in the game. If R square is greater than Darwin-Watson statistics, it means that there is a spurious regression which is running. It means that there are chances that this series are co-integrated. First indication. First prima facie indication is that this series are co-integrated. You will be very happy to interpret this thing, but your reviewer will drop a comment that your R square is more than Darwin-Watson statistics and check for co-integration, which we will see. Is it clear? Please write down somewhere. If R square is greater than if you want to write down very technical thing, I will explain this thing here. Very technically how you will write it down. Is it here or somewhere else? Yeah, here. Yeah, here it is. This rule was given by Granger and Newbold in 1974. If R square is greater than Darwin-Watson statistics, then the regression must be spurious. If R square is equal to 1, then there are chances that it's a spurious regression. Done? Okay, let's come back here. Suppose if I say that all these things are passed and this is my equation. Let's assume that this nothing is violated. So the equation which will be formed on the basis of this is, let me bring this thing here, file, new, open, Control V. my GDP is equal to constant minus 37199 plus 0.513 capital plus 7.285 employment. It is very easy. See, you will have to go here and right click and copy. Right click and copy. So just see what the interpretation is. That if the employment increases by 1 unit, the GDP will increase by 7.285. If the capital increases by 1 unit, then my GDP will increase by 0.513 unit. I repeat, increase in 1 unit of employment will increase my GDP by 1 unit. Increase in 1 unit of capital will increase my GDP by 0.513 unit. Is it clear? Is it clear? Say yes or no. Is it clear? Now, the answer of Mr. Ansur. Again, I go in estimate from here only. And instead of this original series, I make this as log GDP. This also as log capital. This also as log employment. I will copy this in your chat box. Click OK. Got it? All of you? Others, please write. Please write others. Now I'll copy this thing again in the Word file. And now again I will write the equation, that this equation is now as log of GDP Is it clear? Is it clear? Now, Mr. Ansul, please listen carefully. Here, increase in 1 unit, change the GDP by 1 unit. But here the interpretation will be 1% rise in employment will change the GDP by 0.337 percentage. Now it will be percentage. Here it was unit. Done? Is it done? The thing is, 1% change in employment will change GDP by 0.337 percentage. Now it's no longer the original series. We are measuring the elasticity as log is applied. Is it clear? Shall I go to the next level? We are having 15 minutes more and I want to introduce one concept. I hope you are all not tired. Shall I go to the next concept? Say yes or no. Please write in the chat box. Shall I start the next concept? Fine. Now, the new concept which was developed is the co-integration. Their concept was that you cannot make the series stationary, right? But there is a definite thing that two series may be moving in the close proximity with each other. Or in other words, if this goes high, this also goes high. In other words, if GDP is high, money supply is high, you cannot establish the stationarity, but there is a definite relationship between them. Is it clear? Is it clear? Is it clear? This is exactly like in our childhood, we used to play one game. And the name, I don't recall the name of the game, that the teacher used to tie two legs of the students and the pair have to run in the race. There will be pairs which they will have to run in the race. I don't recall what is the name of this game. Anybody knows it? Please write down here. What is the name of this game? Anybody recalls this game? Two legs are tied of students and they have to run in the race. Right? Anybody recalls this? What is this game known as? Anyway, if you don't recall, are you able to understand this concept? Now what will happen is, somebody has, yeah. Now what will happen is that suppose this series moves out little bit, there will be a correction which will be coming from this one, that you are moving out of the track. Please come on the track. And if this moves out, there will be a correction from this side. So both of them are correcting each other and they are running on the tracks. Is it clear? Is it clear? Now, how many co-integrating equations can be there in any model? So they have said, yeah, it's a ECM term, right? It's a ECM term. I always visualize the statistics in games, in real life, and how these concepts can be made simple for you. So I always visualize the statistics everywhere, how can I give you an example which you can readily understand that this is a co-integration. Now the question is that they have said something that if there are two variables, there will be one co-integration equation. Always the number of co-integration equation will be less than number of variables. I found it that why such scenario will be there. Understand? Let us go back to the game. If there are 3 students, how many ropes do we require to tie them? They will be running in the straight line. How many ropes we will require? We will require 2 ropes. All of you are very much clear. We will require 2 ropes. 1 and 2. Is it clear? And the concept is again very simple. Number of variables 1, 2, 3, and the number of co-integration equation is 1 and 2. Clear? Is it clear? Say yes or no. Now in the original example which has been given in the books, they have said, just imagine that there are 2 dogs who have been strapped on and they are moving together. And similarly here also the series are tied with each other and they are moving with each other. Is it clear? Shall I proceed further? Is it clear? Again, coming back to the original model, this model. What to do if there are 3 series? Again, the same thing. Are series stationary at level regression? After first difference, they are stationary, again OLS, but they are not. Then try to run co-integration test. Right? And if there is an establishment of co-integration, if co-integration is found between them, we will be using vector error correction model. And if the co-integration is not there, then we will be using vector autoregressive model. VAR. Clear? Please go on writing these concepts. Vector autoregressive models. Now there is some rapid fire round which is coming for all of you. And you will have to answer me one by one. Series is I0, I1 or I2. Which models I will use? Only one series is there. Which model I will use? GDP, DGDP, DDGDP. Which series I can use? Only one. Which model I will use? Right. All ARIMA models I will use. Now let's come here. All the series are I0, same level, I1, all the series, 2 series, or I2. What I'll use? What I'll use? Normal OLS regression. Right. The original series, if it is not stationary, after doing first difference, they are stationary, then OLS. But the original series is not stationary, base level, but their errors are stationary. Two series are not stationary, but when you run the regression, say for example, if I'm running a regression y is equal to alpha plus beta x, these two are not stationary, but their error is stationary. Then error correction model, ECM. Clear? Is it clear? Same applies with the 3 series. But now, what to do if some of the series are at I0 and some of the series are at I1? What to do? Very nice. Anshul, I think you are reading, you are having a good reading. ARDL model. Okay. Now, some of the series are at I0 and some of the series are at I2. Which model to use? The name of the model is Todo Yamamoto model. Yamamoto model. Todo Yamamoto model. Anshul, are you a faculty somewhere or a scholar? Anshul? Anshul Agrawal, please write down about yourself. You are a research scholar. I really appreciate your hard work. It speaks. Okay. Now, let us go and try to understand the co-integration. There is a difference between correlation and co-integration. Correlation shows a linear association between the two series, whereas there can be more than two series which are co-integrated, and that is known as a co-integration. Right? Understanding the concept, it is necessary that we will have to understand this concept that co-integration is something different from correlation. This is fine. Always remember one thing. Two correlated time series can be co-integrated or not co-integrated. Two co-integrated time series can be correlated or not correlated. See, this is normal OLS. Y is driven by X. So X is a helping hand for Y, or rather the explanation of Y is given by X. Can you see this? Please write down in the chat box. Can you see this? But co-integration is something different. there are two fox which are pulling these strings, right? Two fox. You must have seen two dogs also fighting for some belt, and both of them are snatching each other. What will happen? That if this will be, you will try to pull the rope. This will go this side, and this, if this is this side, and this is this side. This also happens in actual time series. If we want to find out the co-integration, we should have some preliminary points which are there. Both the series should be integrated at the same level. The linear combination should also be stationary. There is a hidden, always there is a hidden message which is given by Durbin-Watson. And we have already seen that thing, that if the R square is greater than Durbin-Watson statistics, there are very fair chance that your series is co-integrated. These are all the equations which are there. Let me show you the last slide for today. This one. See, X I0, Y I0, OLS can be used. X I1, Y X1, co-integration possible. Error terms, if they are stationary, co-integration confirmed. I2 co-integration possible if the error is stationary, co-integration confirmed. One is I1, another is I2, co-integration not possible. Possibly we will go in ARDL model or Todo-Yamamoto model, which is there. Now there are many series, many things which are there. All original time series are stationary. Here we will run normal regression. Second, original time series are not stationary, but their first differences are stationary, error correction model. Third, neither the series nor the residual of the regression are stationary. In that case, we are running auto-regressive distributed lag models. All these three examples we will see on Tuesday. Thank you. I hope you enjoyed the lecture. Over to you, Varun sir.
Thank you, sir. I would like to express my gratitude to all the delegates of the webinar and for making it a great success. Thank you, sir.
Yes, Anshul Agrawal. Yeah, I'll suggest some books also. Yes, Anshul Agrawal, what's your query?
यस सर जब हम रिटर्न और वोलेटिलिटी कैलकुलेट करते हैं उस टाइम पे हमें लॉग लेना चाहिए कि नहीं लेना चाहिए अपने डेटा का?
सॉरी, आई एम नॉट गेटिंग. आप क्या पूछ रहे हैं?
सर जब हम अपने सीरीज का जो हमारा स्टॉक है पर्टिकुलर स्टॉक का जब हम रिटर्न और वोलेटिलिटी कैलकुलेट करते हैं उस टाइम पे हमें ओरिजिनल
नहीं लेना चाहिए. नहीं लेना चाहिए. What will happen is there is a very big problem in this. The return will come negative and the log will not work. Got it? Hello, Anshul. Anshul ma'am, are you listening?
Yes sir, yes sir.
You will get return which is negative and the log of negative cannot be calculated. One, is it clear?
Yes sir.
But they have came out with some concept that if you cannot do that way, add 1 into the largest number. Add 1 into the largest number. For example, if it is minus 9.3, are you listening, ma'am? Anshul ma'am? Anshul ma'am, are you listening? Anshul ma'am?
Yes sir, yes sir.
If it is minus 9.3, you add 1 more to it, so 10. And when you will add 10 to the entire series again, everything will turn to the positive, then apply the log.
जी sir.
Are you getting or not? Please tell me.
Yes sir, yes sir.
Original return, if it is a negative, log cannot be applied. Identify the largest negative number and add 1 more to it. So minus 9.3 is there. Add 10 to it and make entire series positive and then work on it. Yes, if you apply ARMA to original GDP, then it is ARMA, right? But if it is applied to GDP, it is ARIMA. Yes, it is ARIMA. Oppo A3, listen to me very carefully.
सॉरी टू इंटरप्ट सर सर सपोज मैंने रिटर्न कैलकुलेट किया पूरी सीरीज में मेरा मैक्सिमम नेगेटिव रिटर्न हम देखेंगे उसमें हमारा आया -7.23 तो -7.23 में हम 1+1 उस पर्टिकुलर जैसे B9 में आया B9 में
नहीं देखिए -1 2 3 -4 5 -7 which is the largest negative number?
-7.
Add 8 to all of them.
अच्छा 8 sir. Okay.
Right. This will not change the result. I have confirmed this result, and this is the solution which is given by most of them.
Yes, sir. Sir, in most of the papers, I have read this one.
You read this, no?
Yes, sir. Yes, sir. But I am not understanding exactly what they want to be say.
Now, after adding this will become positive, and then you can run the model. Now comes ARIMA. ARIMA. See, GDP was difference for 2 times, and therefore here I is 2. Our model AR1 was significant, so 1. MA was not at all contributing, so it is 0, and therefore our model was ARIMA 120. Clear?
Yes, sir. Sir, one more question.
You applied ARMA to DDGDP, not DGDP and original. See, we worked on DDGDP. Our equation was DDGDP. AR1. So the series was integrated 2 times. And therefore, I have taken 2, AR1, and this is 0. Right. What is another question?
Sir, another question is beta for the bank sector is a 30-day rolling window as the standard beta from the CAPM. Means sir, जब हम बीटा कैलकुलेट करते हैं तो नॉर्मली एक्सेल में हो जाता है रोलिंग विंडो मींस हमें 30 दिन का लेना है 10 दिन का लेना है तो उतने दिन का गैप छोड़ के हम बीटा कैलकुलेट करेंगे
Rolling window forecasting is another whole big topic which is there. If time permits, I will share you how to work on rolling windows, which is there in I am having it here or not. Yeah, forecasting rolling window in EViews. There is a specialized option of running it. If we are not able to do it here, I will send you the command by which you can use a rolling window in EViews.
Okay, sir. Sure.
It's a forecasting technique of doing it.
Okay.
हेलो सर हेलो सर आपने अरीमा मॉडल लगाया जब तो उसमें सेकंड डिफरेंस लिया डी जीडीपी का सेकंड डिफरेंस तो हाउ टू नो कि सेकंड डिफरेंस पे जाना है व्हाइल अप्लाइंग एआर एंड एमए मॉडल
DDGDP is a stationary model, is a stationary series.
Sir, DGDP is also stationary.
DGDP का stationary is it stationary? Was DGDP stationary?
Yes, I think it was.
Let me check. No, it's not stationary. DGDP is not stationary.
Okay, thank you, sir.
It's not stationary.
Excuse me, sir.
Oh.
Sir, I have a question. I have 2 series, stock market index, and I want to check co-integration between them. So first of all, I have converted them into by taking natural logarithm into return.
Wait a minute. May I know your good name?
Hanji, sir.
May I know your good name?
Monica.
Yeah, Monica.
Hanji, sir.
Are you in hurry?
No.
Then wait for Tuesday. We are going to check entire procedure and the entire trajectory what to do. Okay? I'll explain entire way.
Okay, sir.
I hope you are not going to submit thesis tomorrow.
No, sir.
Okay, just wait for Tuesday, right?
Okay, sir.
Right. Okay, thank you.
Sir, I have one last question.
Yeah. Go ahead.
सर स्पिल ओवर इफेक्ट है, हम ईव्यूज में भी देख सकते हैं कि आर में ही?
स्पिल ओवर इफेक्ट माने?
सर हमें पर्टिकुलर इम्पैक्ट देखना है, एक स्टॉक का दूसरे स्टॉक पर कितना इम्पैक्ट आया, शॉर्ट टर्म के लिए, लॉन्ग टर्म के लिए.
हाँ, you can see it here. Also, that we will see. Variance decomposition हम करेंगे ना, war में देखेंगे how much spillover effect is there.
सर फ्रॉम टाइम डोमेन एंड फ्रीक्वेंसी डोमेन दोनों से?
हाँ, दोनों से देखेंगे. We will see from both of them.
ओके. और सर जो उसका नेटवर्क एक डायग्राम बनता है जैसे ए एरो बी करके, सर वो भी बन जाता है EViews में?
You share on the screenshot and then I will come to you. Right?
Okay. Thank you, sir.
You share on WhatsApp what the diagram is.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Any other question?
No, sir.
If anyone has more questions, can unmute and ask.
Okay, Arunima ma'am, there is no question, so we will end the meeting here. Thank you.
Yes, sir. Sir, thank you for this interesting session.
Also,
Yeah. Yes, Dr. Srivastava.
sorry to interrupt you, sir. At the last moment, actually, this is new topic for me. So, can you suggest some basic books for understand the same, sir?
You should always start with Damodar Gujarati, basic econometrics.
Okay, sir.
Then you go to use Ramu Ramnathan.
Ramu.
Ramu Ramnathan.
Okay, sir.
Then you read Woolrich.
Bullrich.
Yeah, Woolrich. Then you read Greeny.
Greeny.
Greeny. Greeny.
Okay.
Then you read G.S. Madala.
G.S. Madala.
Yes, Madala.
Okay.
Then you read Estrio Demetrios.
Estrio, sir, then?
Demetrios. So you are a faculty somewhere, Dr. Srivastava?
Yes, sir, I am faculty.
Where you are teaching, sir?
I am serving in agriculture institute, sir. I am working as a professor in HAT. But I am trying to learn this basic new concept. Actually, at that time and year 98, this was the new not existing.
Right.
I am trying to learn the same, sir.
Right. And where is located this university, sir?
So Navsari Agriculture Institute. Sir, actually, I am trying to call you and many times regarding one. Actually, we are going to conduct one 11 days training with the help of ICR. So I trying to call you as an expert, sir.
Thank you. So you are nearby to me.
Exactly, sir. I visited this Indian Council of Social Sciences. Mr. Mehta was there, sir. In fact, Desai was there, sir.
Yeah. I know it. Chalo, anyway, good.
Please. Thank you, sir.
Yeah. Thank you.